law, which is a very interesting topic in the electrical circuit. Now, if you observe the basic electrical circuit diagram, we will be containing one conductor which is passing the current through it, right? And it is closed with the help of a battery. Now, we will be observing that the flow of current is directly proportional to the potential difference between the edges of the conductor. That means the two edges having the potential difference of V is directly proportional to the flow of current in the conductor. That means the amount of electrons which are flowing through the conductor will be directly proportional to the difference of potential. Now let us see this graph in order to understand the proportionality constant. That is, if you see the potential difference, it is plotted on the y, and if you see the current, it is plotted on the x, that is horizontal line on the graph. Now if you see, I have marked the points of various currents and potential differences across the line, and I have marked it with a pointer. Now we will be seeing that the line which is observed on this chart or on this graph sheet is a straight line which is passing through the origin and is directly proportional to the flow of current and to the flow of voltage, right? Now here you can see and you can observe this flow of current in the diagram. Now we will be seeing this diagram. See, this is a straight line which is passing through the origin. That means by this we can conclude that the voltage and the current are directly proportional and they are proportional to each other. Now we will be seeing that voltage and current graph for nichrome wire. That is, nichrome wire is a wire which is consisting of a ability to allow the flow of current, that is flow of electrons, that is valence electrons. So here we have seen the properties of this nichrome wire. Now let us see the German physicist, the great physicist Joules Ohms. He has defined and he has discovered the difference and the direct proportionality between the voltage and current. Therefore, with the help of the scientist's name, that is Simon Ohm, the Ohm word of the scientist has taken out, and that Ohm word is given for the resistance. Now let us see what is resistance. That is, see, we have from this graph we have derived that V is directly proportional to current I. Okay. Now we will be seeing that V by I. Now if we bring this I to the denominator side, then it will become V by I equals to constant. Okay. Now this constant is said to be as R according to Simon Ohm. That means R is a constant which is makes the voltage and current in a proportional way. That is, we will be saying that V equals to IR. This V equals to IR is said to be Ohm's law. This is the Ohm's law which is valid for all the metallic wires or all the conductors when the temperature is constant. Remember the point, the temperature is constant when this Ohm's law is valid. It is applied when the temperature is maintained constant only. Now we will be seeing that voltage is equal to the product of current and resistance. Resistance here acts as a constant. Therefore, we will be giving that R as a resistance. The symbolic representation is R, and the SI units of resistance is Ohm, that is of the scientist named Simon Ohm, and it is a Greek letter Ohm. It is a symbol of resistance, and resistance is defined as V equals to IR. Therefore, R is said to be V by I. Okay. Thus, we have derived this formula for resistance, that is voltage by current. Now here we define 1 ohm of resistance equals to 1 volt or 1 volt of voltage, which gives the amount of current, that is 1 ampere of current. Then we will be saying that rate of change of voltage to the current as resistance. The symbolic representation is 1 ohm, that is 1 ohm equals to 1 volt per 1 ampere equals to 1 unit of resistance. So here we have learned what is Ohm's law. Ohm's law is voltage equals to the product of current and resistance. See here, V equals to IR. That means voltage and current is having the direct proportionality, and those constant is said to be as resistance. With the help of this diagram, I hope you can understand that voltage is directly proportional to current. Okay. Now let us see the factors on which resistance of a conductor depends. That means previously we have learned about the Ohm's law, that is the resistance which is acting as a constant between the voltage and current. That means voltage is directly proportional to current, but in order to maintain this direct proportionality, we will be using the constant, that is resistance. So this resistance depends upon some factors. Let us know that interesting topic regarding the resistance factors. Let us do one small experiment in order to understand the factors which depends upon the resistance. That is, if example, let us take this a circuit. It is a closed circuit in which the current is passing. Suppose take this is as a switch, and this is as a cell or battery, and this is ammeter as shown, and this is a closed switch. Okay. Now this is the conductor in which I am taking a nichrome wire. That is, nichrome wire consists of free electrons which is accessible for movement of electrons, and it acts as a good conductor of electricity. Therefore, I am preferring nichrome wire. First, I will be testing the nichrome wire. That means I will be taking the nichrome wire and I will be connecting it to the circuit, and I will be on the switch. Now I allows the current to flow through it. Now I will be noting down the amount of current which it is passing through the nichrome wire. In the second step, I will be using double the length of the nichrome wire. That means if for example I have taken 10 centimeters of wire in first experiment, then I will be taking 20 centimeters of nichrome wire in second experiment. That means I will be using 20 centimeters of nichrome wire, and I will be calculating the amount of current passing through the help of ammeter. Now in the third experiment, I will be taking the other wire. That means now I have taken nichrome wire firstly. Now secondly, I will be taking the copper wire. Assume that it is a copper wire, and I will be allowing the flow of current, and I will be calculating the amount of current passing through it. Right? Now fourth step, I will be using the higher thickness, means larger thickness or long. It means if I taken a copper wire of thinner length in third experiment, I will be taking a thicker wire. That means a long wire, thick wire, fat wire. For example, to understand fat wire or thicker wire in the fourth experiment. Okay. Now here I have differentiated the length, the different materials or metals, and the area of cross section. Right. Now thicker and thinner, it differs in the area of cross section, and single length and double length, it differs in the length. And copper and nichrome wire means I have taken two different metals of different properties. Now by doing this all four experiments, I will be seeing the amount of current flowing through the ammeter. Is the current flowing through the ammeter is same for all the four experiments? No, because it varies along with the resistance. That means resistance depends upon these factors. The factors on which the resistance depends upon are, the first factor on which the resistance depends is length. That is, R is directly proportional to the length of the nichrome wire, and R is inversely proportional to the area of cross section. If the area of cross section of a wire is higher amount, then the resistance flowing is lower. That means they are vice versa. That is, indirectly proportionality is maintained between the resistance and the area of cross section of a circuit. So we will be seeing that these two properties, that is length and the area of cross section of a resistance of the circuit. Okay. Now we will be seeing that ammeter reading decreases to 1.5 when length of the wire is doubled. That means ammeter reading decreases when the length is increased. That means the resistance offered is high when the length is more. Therefore, we can say that resistance is directly proportional to the length, and at the same time resistance is indirectly proportional to the area of cross section of the conductor. Now let us see the area of cross section. And also we will be seeing the nature of the materials, right? We have seen the nichrome and the copper wires. So we have to differentiate the properties between those materials. If at all we use nichrome wire, it is having a less values, that means 30 ammeters is readable. If at all we take copper wire, it is around 50 to 60 ammeters of reading has been taken out. That means copper wire is more visible or more flexible to allow the flow of electrons through it, and thereby copper wire is said to be as a more good conductor when compared to the nichrome. In the same way, there is a difference between the alloys and the metals. Alloys does not allow the flow of electrons as much when compared to the flow of electrons in metals. Therefore, alloys are said to be acting as insulators or bad conductors of electricity, and whereas metals are acting as a good conductors of electricity, right? And they are said to be as conductors. Now let us see the formula for resistance, which depends upon the factors. Now resistance is defined as R is directly proportional to L and R is inversely proportional to area of cross section. Therefore, by combining these two equations, we will be getting R is directly proportional to length by area. So this proportionality constant, in order to maintain this proportionality constant, we are using the rho. This is a Greek letter. Rho is defined as the proportionality constant, and it is the symbol for rho. This is the Greek letter, and it is named as resistivity. Resistivity of a conductor is said to be as rho. I hope you got the difference between the resistance and resistivity. Resistance is used as a constant between voltage and current, whereas resistivity is used as a constant between the resistance and the factors on which the resistance depends, that is length and the area of cross section. So rho is defined as the resistivity and it is a constant of resistance. Now let us see these four experiments we have done, and we have concluded that resistance depends upon length and area of cross section, and these are the observations we have calculated, and you will be seeing this on the board, on the notice. And rho is said to be as electrically resistivity, as I said, and it defines the characteristics or properties of materials which we are using in the system or in the conduction process. That is, if at all the resistivity varies between the materials, so for copper wire it is around 1.6 and for nichrome it is less than that. That means the resistivity is varying for different metals in comparing to their properties. Now we will be seeing the resistivity values as 10 power minus 8 ohm meter to 10 power minus 6 ohm meter. That means these values around 10 power minus 8 to 10 power minus 6, those values are said to be as smaller resistivities, that means lower less resistivities, that is 10 power minus 8 to 10 power minus 6, and these are said to be as good conductors of electricity because they are having of lower resistivity. So they will be offering us low resistance, that means they will be allowing the flow of electrons through them, and thereby the conduction will be taken place, and so they will be acting as good conductors of electricity. Simple, right? Now we will be seeing the another case, that is 10 power 12 to 10 power 17 ohm per meter. Here this is the 10 power 12 to 10 power 17. This is the higher rate of resistivity. That means they are acting as bad conductors. Simple. The best examples for bad conductor are wood, rubber, glass. Those all things does not allow the flow of electricity through them. Okay, and based on the resistivity, the flow of conduction takes place, and the resistivity value determines the properties and characteristics of metals. Hope you have understood the resistivity and resistance. R equals to resistivity by L by A. This is the formula for resistance and resistivity, and rho is defined as a Greek letter and is a symbol for resistivity, and the units are ohm per meter. The SI units for resistivity are ohm per meter, and we will be using these all formulas to solve some problems, and thereby we can understand them briefly.